When there are so many different products and services described as fibre internet, how do you tell them apart? And why is it important to understand the differences? What's the difference between a fibre connection that costs £50 per month to one that costs £500 per month? In the next few minutes, I'm going to run through the main differences in the most common fibre technologies and explain what you need to look for when deciding what you actually need. So let's start with the basics. To connect your office to the internet, the connection is actually made up of various networks. Firstly, you have a connection to the wholesale or backhaul provider. They then in turn connect to the internet service provider or ISP. Now this is the company you typically buy your service from and could be the same company that provides the backhaul service. The ISP then connects you to the public internet. So when we're talking about fibre internet, we're actually referring to some element of this bit here, the bit that connects your office to the wholesale or backhaul network. To explain the differences in the product you buy, I'm going to focus on two key areas. Firstly, the access media. What is this connection from your office actually made of? Secondly, we'll look at the service overlay, how the access circuit and backhaul network is combined to create the product or service that you actually buy. So let's start with the access media. Back in the 1990s, the first common broadband service was ADSL. This used a copper analog phone line between your office and the local BT street cabinet, and then more copper cables back to the BT exchange to carry your data signal. As data signals over a copper wire degrade significantly over distance, bandwidth was under 8 megabits per second downstream and 2 megabits per second upstream, and often much lower. This is also why broadband services were sold as up to a particular bandwidth, as it was hard to predict what speed could be achieved over the copper wires. We're not going to spend too much time on ADSL, as it isn't a fibre circuit and is largely being phased out. The first great technical advance and the first time fibre internet was mentioned was when BT Openreach replaced the copper line between the cabinet and the exchange with fibre. This gives us a fibre to the cabinet or FTTC connection, sometimes called VDSL. As you have shortened the copper distance, the signal degradation is much less, so speeds of up to 80 megabits per second downstream and 20 upstream became possible. This is still the most common internet connection used today, particularly in residential or small business scenarios. More recently, the cabinet equipment has been further developed to create a product called G-Fast. This uses the same copper wire to offer up to 330 megabits downstream and 50 upstream. This, however, is only available to those within a couple of hundred meters of an upgraded cabinet, so will have limited availability. Now we know that copper wires are the limiting factor, so the natural advancement is to replace all the copper with fibre. By doing this, we get fibre to the premise, or FTTP. Now, FTTP networks are based on a technology called GPON, or Gigabit Passive Optical Networks. The street cabinets are replaced with network nodes where fibers are spliced and consolidated in a complex branching network all the way back to the nearest core node, which is usually at the local exchange. Now, these circuits can offer bandwidth up to 1 gigabit per second downstream and 115 megabits per second upstream. But bear in mind that these fibre routes are shared, so connections are likely to get congested at busy times, which will result in variable speeds. The last type of fibre connection to talk about is dedicated fibre, often referred to as a lease line or Fibre Ethernet. And as the name suggests, this is a dedicated fibre all the way between your office and the provider's network. It's no sharing, it's all yours. Now these are typically 100 megabit, 1 gigabit, or nowadays even 10 gigabit capacity, and you will rent a given bandwidth. For example, you may opt for 500 megabits on a 1 gigabit capable bearer, and you will get the entire 500, both upstream and downstream. Let's take a moment to summarize what we've just covered. Fibre to the cabinet based on VDSL technology uses copper to the cabinet and fibre back to the exchange. It has a maximum bandwidth of 80 megabits per second down and 20 up, and its performance is variable based on the distance to the cabinet, i.e. the length of the copper wire, and any congestion on the fibre link to the exchange, as this is shared with other customers connected to the cabinet. Fibre to the cabinet based on G-fast technology is very similar, but does give higher bandwidth if you are close enough to the cabinet, up to 330 down and 50 up. Fibre to the premise is based on GPON technology and uses fibre throughout the journey. It can deliver bandwidth up to 1 gigabits per second down and 115 megabits per second up, but is also shared infrastructure, so likely to get congested at busy times. Dedicated fibre or lease lines consist of a dedicated fibre all the way to the exchange, so have no congestion issues, and can provide symmetric circuits as large as 10 gigabits per second, but more typically 1 gigabit per second. So now we understand the access technologies in a bit more detail and their limitations, let's take a look at what services can be delivered over these connections. The service is, after all, the product you buy, whereas the access circuit simply facilitates the service. I'm going to start by defining services into two main categories. Historically, these were very different, but the services are starting to blur a little. With broadband services, you'll get an asymmetric profile, so higher downstream bandwidth than upstream, and broadband services operate over shared infrastructure, so will be congested at times. This gives you inconsistent performance and are therefore unlikely to be backed by any performance SLA. This means that network-sensitive applications like voice over IP are going to have problems at times. Conversely, looking at Ethernet services, these were historically delivered over dedicated infrastructure, and this allows for symmetric bandwidth profile. No sharing, so no congestion, and consequently they perform consistently and are SLA backed. In recent years, there's a third category that's been developed. This offers an Ethernet service over a fibre to the premise or fibre to the cabinet access circuit. And these combine the cost and availability benefits of the shared access infrastructure of FTTP and FTTC with an Ethernet level service on some or all of the contracted bandwidth. So you'll get symmetric or asymmetric profiles depending on the product choice, SLA-backed performance on all or some of the network traffic, and this means you can achieve consistent performance, and as these circuits are suitable, and as such these circuits are suitable for applications such as voice over IP. So now let's bring all this together. ADSL connections only support broadband services. The use of copper wires makes the bandwidth distance dependent, and a technique called dynamic line management is used to keep the line stable. This, however, can reduce the maximum bandwidth at times. The infrastructure from cabinet to exchange is shared, and with all of the above factors considered, you're not going to get a performance SLA from your provider. So these circuits are generally unsuitable for voice over IP. I will caveat that statement by saying that there are specialist variants of ADSL, such as SDSLM, which are used for voice over IP, but conversely not generally suitable for general internet access. Moving on to FTTC broadband using G-fast technology, we can get much higher bandwidth, but with the copper wires in use, we effectively have similar challenges. So again, these circuits are typically not suitable for voice. There are options such as Spitfire Voice Assistance, which can optimize these circuits if VoIP is required, but there's no guarantee on consistent performance. Sticking with FTTC circuits, but this time VDSL based, we also have the same challenges as G-fast and ADSL. However, you can get an Ethernet service that utilizes the same access circuit. Now this is called FTTC Ethernet or Ethernet over FTTC. The wholesale provider will use a different backhaul network or otherwise prioritize the traffic over broadband traffic across that backhaul network. This allows the service to offer performance SLAs on all or part of the bandwidth. And this therefore can make circuits suitable for demanding applications such as voice. If we then move on to FTTP, We no longer have the issues caused by copper wires, but we cannot forget that the infrastructure is shared. This is why FTTP broadband is rarely offered with a performance SLA. Like FTTC Ethernet, you can also get FTTP Ethernet or EO FTTP. Combine the Ethernet backhaul network with higher bandwidth, and you can get options with symmetric or asymmetric bandwidth and performance SLAs for some or all of the bandwidth. With some clever network configuration from your ISP, these circuits not only support voice over IP, but also allow you to prioritize other traffic such as video calling. Lastly, we come on to dedicated fiber circuits. These only support Ethernet services, which are fixed symmetric bandwidth, and as the infrastructure is dedicated, a performance SLA on the entire circuit can be offered. However, note, I say can be offered. Service providers sometimes look to reduce costs by shaping or contending the backhaul traffic or using low-cost backhaul services. These will impact the performance of your circuit, so please make sure you're checking your SLA. Hopefully you now have a better understanding of what's currently available in the market and that there are significant differences between the large range of fibre internet services available. I'm going to leave you with a couple of takeaway points. When you're considering fibre connectivity, please make sure you know which fibre technology you are looking into. And secondly, you can only compare services by knowing the SLA. So please make sure you ask for a copy before making any decisions. If you need to know any more, please don't hesitate to get in touch. Thank you for your time.